Hey folks, welcome to part 2, lecture 2-3. So in the first part we talked about electron arrangement and energy levels, and now we're going to introduce valence electrons. All right, so just by definition, valence electrons are the word we use for electrons in the highest energy levels. Or if we remember the representation like this, that would be the outermost ring. So you can just remember uh, the valence electrons are the ones in the um, energy level corresponding to the row that the atom is in, if that makes sense, right? So if you have an atom in or an element in row 3, then the valence electrons would be the electrons in energy level 3. Okay, so here's a representation of the group 1A metals, alkali metals. That would be this group right here, right? Hydrogen is not technically a metal, but it uh, follows the pattern of this group, so it's included. Um, and so this is group 1A, and if we look at the uh, energy levels, their energy level diagrams is what these are called. We see hydrogen, as we saw before, has one electron in N1. Lithium has one electron in the N equals 2. Sodium, even though we're all the way up to 11 electrons, there's only one in the highest energy level, which is 3 now. And continuing on, potassium has 19 total, but just one up there in the highest most energy level. So we sense a pattern, right? The group 1A has one valence electron. And that makes sense, right? Because it's the start of a new row. So we're putting electrons into a new energy level. Okay. This is an example of periodicity, which is repeating patterns found in the periodic table that we talked about why these groups are grouped together, right? And this is one of the big things is that they have the same or similar electron arrangements and the same number of valence electrons. All right, let's move over one to group 2A. And so if we looked at what we had for beryllium, we're just adding one more electron to the N equals 2. So now there's 2. Going down to magnesium, element number 12, we have 2 electrons in the N equals 1, 8 in the N equals 2, and 2 in the N equals 3. So 2 valence. And calcium has 2 in N equals 1, 8 in N equals 2, 8 in N equals 3, and 2 more in group, N equals 4. So group 2A has 2 valence electrons. And the pattern continues. So we see that group 1A elements have 1 valence electron. Group 2A elements have 2. Group 3A has 3, and so on, up until group 8A has 8 valence electrons. And a filled valence energy level, right? So it's filled, so then the next one would add to the next level. The only exception to this is helium, right? Because helium is all the way off to the right of the periodic table for other periodicity reasons, but it does not hold 8 electrons because it's N equals 1. But otherwise, this holds. So the guiding rules, this is important here. Group XA, so 1 through 8, has X valence electrons. These are the main group elements. So we're not talking about transition metals. just the ones that we designate with A. And we also know that period N has energy level N as the highest. Okay, so these two guiding rules will get you pretty far. So let's do a question. How many valence electrons in barium and carbon? So you have to find it on the periodic table, look at what group it's in, and then from there, you know how many electrons. So pause this, try it for yourself. All right, did you find it? So barium is atomic number 56. It is in the n equals 5 period. I'm sorry, 6 period. And it is in group 2A, right? And so right away, once you find it and you see it's group 2A, you know that it has 2 valence electrons. All right, carbon. We talked about that one before, but now we have new terminology with valence electrons, and we know that it's atomic number 6. It's in the n equals 2 row, and it's group 4A. So it has 4 valence electrons. Before, we talked about it has 2 electrons in the n equals 1 and 4 electrons in the n equals 2. And now we see that those 4 are what we would call valence electrons. Here's a multiple choice question. Select the correct match between the element and the number of valence electrons. So go ahead and pause this and answer for yourself. And now that you're back, you know the correct answer is chlorine, right? Because that's in group 7A. So it has 7 valence electrons. By the way, what is the name of group 7A? That's one that has a special name. Starts with an H. It's the halogens. Okay. Here's another question, multiple choice. Identify the element with this electron arrangement. There are 2 electrons in the n equals 1 and 5 electrons in the n equals 2. What is it? Okay, if you answered for yourself, you're back. Well, a couple ways to approach this. We know that it must be in the n equals 2 row because that's the outermost row. There's 5 electrons there. And so we also know if there's 5 electrons, it's in group 5A, which you go and you look n equals 2, group 5A is nitrogen. Okay. Another thing you could do is you see that there are a total of 7 electrons. And so you just go and you find element number 7 or atomic number 7, and that's nitrogen. Okay, so there's 2 equally valid approaches that you can take. And actually, I'd suggest do both just to confirm, right? And if you get the same answer both ways, then you probably have a pretty good understanding and you probably have it correct. Okay, we're going to finish up part 2 talking about atomic size. So remember we said that the volume of an atom is determined by where its electrons are. Okay, and now we've been talking about electron arrangement, the energy of electrons, and distance from the nucleus of these electrons. And so, can you make any predictions or estimates on the size of atoms, or at least the trends in the size of atoms? So think about electron energy levels. and periodicity. So think about what happens, what can you make a prediction on the size of atoms as you go down a row? Well, I included this representation here because I think this is helpful, right? And we see that if we add uh, a circle around the outside and put the electrons there, they are farther from the nucleus. And so the overall volume of the atom would increase as you go down. And remember, we said also the electrons at the higher energy levels are farther from the nucleus. So we see that we would predict that the size of atoms would increase as we go down. Now, what about as we go across? What do you think? Well, as we add more electrons, we're adding them to the same energy level, right? Um, and so we're adding them, right? We're not adding them farther away than any of the others. However, this atomic size does change as we go across. However, it's not to get bigger. Actually, it decreases. So atomic size decreases as you go across a row. Why? Well, think about what's happening in the nucleus. As atomic number increases, number of protons increases, and by the time you get to neon, there are more protons in the nucleus than there were in lithium, and opposite charges attract, right? So there's more positive charge in the center, and due to electrostatic attraction, there's going to be, it's going to pull the electrons in, just hold them a little bit tighter as you go across a row. So even though the energy level is the same, it's not so much about adding the electrons, it's about adding the protons. And so there are more protons as you go across, so it's going to kind of pull those electrons in slightly. So bonus question, where would the largest atom be and where would the smallest atom be? Here's a way of showing this. So the largest atom, right, is all the way at the bottom and all the way to the left. Which is francium. And the smallest, right, is all the way at the top and all the way to the right. So helium is actually the smallest atom. And then you can see the trends here in between. So increasing going down, decreasing going across. All right, we'll end this one and we'll come back to part 3 and do some more practice problems.